Hello and welcome to the Blazor Community Standup. I'm John Galloway. I'm filling in for Dan this week. Today we're joined by Safia,
Hey.
and we also have Ondrej, and I'm saying
Hi.
that wrong, but I'm doing my best, and Javier also. So we'll just jump right into it. I also will make apologies in advance because I am juggling some things. We have maybe a preview of dotnet going out today. So
Yay!
let's see how that
Very
goes.
exciting.
Yes. Yep. So cool. All right. I think we can just jump right into it. So I think, Ondrej, are you first?
Yes, let's go.
Okay. You ready for me to share your screen?
Okay. Well, yeah, let's go.
Okay. Here we go.
Well then, let me introduce what we are talking today. It's gonna be one topic, and that's validations in ASP.NET, and in particular in Blazor, with some notes on minimal APIs, because we have our great colleague Safia here. First, before we get to that, let me give you some context, which is gonna be this one slide presentation. Because I wanted to have something to talk over. What we are bringing in .NET 10 for Blazor is improved validations. Previously, validations, meaning validations for your forms or for your other components that implement edit form and edit or use edit form and edit context components. And this previous implementation had some limitations that users were complaining about for years now. I mean, justifiably. And these limitations were based on the original, validation implementation in .NET, which is based on the system.component model.data annotations namespace, which many of you might be familiar with. And this is the attribute-based validation, which has been in .NET since like .NET Framework 4, I think. And this implementation uses validation attributes, which allow you to declaratively specify rules for properties and classes that you use as models, and has been used in various frameworks since then. And also provides a public API for manual validation and customizability based on custom attributes and iValidatable object interface. But the main limitations of this implementation was that it doesn't support nested validations. So if you have an object which has some nested properties of object types, the validator won't give you validations for the nested properties and doesn't validate collections. And also, the whole implementation is reflection based with some performance cost, and it doesn't play nice with AOT. So there has been a concentrated effort for .NET 10, originally driven by Safia, or still mainly driven by Safia, which was to provide new implementation for validation infrastructure that could be used across frameworks, and which would be search generator based, and also would support more advanced features such as nested validations. But to introduce this implementation, I would ask Safia to do it herself because she's the expert, and then we'll go back to Blazor itself. Okay, thank you.
Ooh, no pressure. All right, I'm gonna bring up my monitor onto the view, and sorry.
Sorry about that.
All right, okay, so I'm gonna be doing a bunch of just showcasing the code. If you want to follow along, the code that I am demonstrating is in the sample app repo that I'm about to post, so you can kind of follow along and see what all is there. Um, so what's the entry point for using this new extensible validation model that applies for both minimal APIs and Blazor? If you were tuning into the stand-up a couple of months ago, Dan and Mike showed this add validation API that is a new API in the Microsoft Extensions validation namespace. Put a pin on that because it's Microsoft Extensions validation, which kind of really underscores that this is meant to be a generic API that can be used to support validation in multiple frameworks or scenarios. So you have this add validation API that you can invoke on your DI container to register a set of default validation related behavior. And the best way to start kind of understanding how it works is to dive in a little bit into the code that gets generated when this call is present in your application logic. So by default, this new validations implementation comes with a source generator that we use to do type discovery. Type discovery is like a pretty common prerequisite for a lot of these like serializers or binders or validation type things where you have to go and understand what are the types that I need to serialize or or validate system text JSON does something similar with a source generator. Minimal API and MVC have runtime and AOT friendly implementations depending on which. So behind the scenes, this source generator is doing the work of figuring out what are all the types that are being referenced in the implementation and what validation qualities exist on them. So if you pop into the repo, you'll see that the code that is generated by the source generator is actually committed. So you can kind of inspect it and see what happens. So I've jumped into the generated code and okay, first thing you see, intercepts location attribute. If you are familiar with this attribute, you might be familiar with the interceptors feature in the compiler. If you are not, the intercepts location attribute essentially allows you to source generate an implementation of a method at compile time, annotate it with an attribute, and that is a clue to the compiler that whenever it sees instances of that invocation site, instead of calling whatever default implementation would exist at runtime, it should instead call this implementation that exists at compile time. And so I have been using and abusing the intercepts location attribute for a variety of things since .NET 8 when we did request delegate generator for minimal APIs to support AOT. And one of the patterns that I've really enjoyed using it for, specifically in .NET .NET 10 for both this validation resolver and for also the OpenAPI XML source generator, if you're tapped into that, is you can actually add it to an add validation method that targets the DI container, and you could use it to wrap extension methods to essentially add custom behavior to whatever validation call you're invoking. So this particular pattern is going to say, find the add validation call site in the user's code, intercept it by adding some default configuration, which we'll see here. It's saying intercept it by adding this generated validatable info resolver that we will then, examine or reflect on at runtime. And we'll still kind of delegate back to the add validation method that you call. So if you have additional customizations that are registered on it, those will apply too. So this is kind of like a fun little pattern that you can do with interceptors on methods that target DI containers. And this is kind of the entry point for all this entire experience, where you get this kind of magical behavior where with an add validation call, and optionally some discoverability attributes, all of the validation infrastructure lights up. Resolvers might trigger a recollection in your head because system text JSON has a pretty similar API for its type info resolvers. They're kind of defined in a chain, and you can register multiple resolvers to query system text JSON for information about how different types should be deserialized or serialized. The same concept exists here in this validation layer. There is a notion of validation resolvers, which implement a particular interface, and you can chain many of them into an API and kind of codify or extend resolver or validation behavior in the implementation as you'd like to see fit. So here, by default, when you activate the implementation, we generate a validatable info resolver. that will discover all of the types that exist in your application and emit the validatable info, type info that's correlated to them. And we could take a peek at the implementation that's generated. We can see it's pretty much only two methods that iValidatable info resolver implements, and they could be used to provide information about what properties exist on a type and then what validation attributes or validation relevant behaviors those properties have. So all of this gets source generated. Because it's source generated, we don't have to rely on reflection at runtime in order to discover these things. So it's inherently a trim-friendly pattern for type discovery. And then what we source generate or emit is just kind of like state. It's type infos that say, this is not actually doing the validation, but it's giving you clues about how you should do the validation. And then at runtime, there are default implementations of these validatable type infos that will actually go through and do the work of walking through the types that are consumed and validating them by default. And so all of that can happen at runtime based on the state or the data that we could discover at compile time for all of this. One kind of interesting thing that I want to call out about the minimal API implementation, and it's kind of unique to minimal, as Ondrej talks about Blazor, is for minimal API, we have a pattern for being able to discover minimal API request handlers at compile time. It's the same pattern we use for the request delegate generator to support native AOT. And so because we already know how to inspect your handlers and we can look at these delegates and we can discover parameters and whatnot, for minimal API, you don't actually need to put any specific attributes on your parameters or types to tell minimal API, hey, these need to be validated. Calling add validation at the top level is sufficient enough. And because we can auto discover it with the source generator, that will happen automatically. So I guess one distinction here is that for minimal API, if add validation is called at the top level on your DI configuration, then validation is an opt-out behavior. You have to disable it on a per endpoint basis. And there's an extension method for doing that. So just to like quickly prove it works in the sample app, we have a bunch of endpoints that we can query. Here's one with customer data that has an invalid email format. This is codified by the fact that on my customer class, I have an email address attribute, which is a data annotations based attribute on the email property. And so if I send this invalid request, I should get back a 400 request with a problem details payload that kind of describes what went wrong here. So that's pretty neat. I want to close by talking about custom validation resolvers. So earlier we talked about how resolvers provide information about the types that should be validated, and they exist in a chain that the implementation will query at runtime to figure out what the validatable type info is and how it should do the validation. In addition to the validatable info resolver that gets generated for you by the source generator, you can also declare your own ones. So if I scroll back to the top, you can see in this add validation call, I've provided a callback that registers a business rule validation resolver to my resolver chain. So this is going to exist in addition to the one that's source generated, and it will also be queried. And in this custom implementation, I've implemented the same iValidatable info resolver method. It exposes two APIs for generating validatable type info for types or validatable parameter info for things that appear as parameters to your method handlers or what have you. Um, and this is really where like the magic of this customizability exists, because here I can do whatever I want to structure my validation implementation. For example, I might have types where I don't want to put validation attributes on them. Or maybe I want to declare custom implementations of validation attributes that don't actually appear on the type. So I can instead define a validatable info associated with this. So I might have a business product, which is like my core type, and then the validation info related to it in the validatable info type. And this would just kind of encode all of the properties that need to be validated and whatever custom attributes exist on them. So I could say a SKU is a required attribute that needs to comply with some custom SKU validation logic that I have. And so I can say, okay, I have my type in one place, and then I have my validatable info with the attributes in another. These validatable type infos are abstract classes that you will need to return out of your validatable info resolver implementation. And in addition to being able to customize what validation attributes exist on them, there is also this fun little thing you can do. And let me jump into the discount parameter validatable info type, which I think showcases what I want. So validatable parameter info is the type that you return from your iValidatable info resolver for documenting how a parameter info gets validated. You can expose the validation attributes that exist on it, but you can also override the built-in validate async method that type infos implement. So by default, these validatable type infos will implement a method that understands how to walk the type hierarchy, validate properties as it goes, aggregate validation errors, so on and so forth. And that is kind of part of the default standard behavior that is shared across Blazor and Minimal and any other implementations that want to take advantage of the built-in logic. But you can also override that logic or wrap it. You can override the validate async method, call the base implementation if you'd like or not, write your own custom implementation. So this is yet another hook for you to be able to customize the behavior of validation in the layer. I know this was a lot, and it's like a little bit of an iceberg, which is kind of intentional. The idea is that if you are just somebody who's writing minimal APIs or building stuff with Blazor, all you have to do is call add validation, and you kind of don't have to worry about too much else. But then if you want to go further or just play around with the internals, this validation support is really built on like a meta framework that you can extend with your own resolvers and custom behavior and stuff like that. So yeah, that is kind of a bit of a behind the scenes. And this shared infrastructure is exactly the infrastructure that Blazor uses for its implementation. And I think, Ondrej, unless I missed something, I will hand it off to you to talk about Blazor and how validation works with Blazor.
Sure, go ahead.
Yeah.
Okay, well, thank you very much. The reason we wanted to show you all of this in the Blazor stand-up is that all of this is added to the Blazor as well. All of these APIs will you will be able to use and use for customization as well. But our priority first was to build upon this, new APIs in such a way that you can just upgrade your Blazor apps, almost in place. So let me show you how the new validations works in Blazor. What we see here is, standard Blazor component, which has one form with some, fields and etc. I will comment later on it in more detail. But the validations are actually used in the same way as before. So we have an edit form, and inside it we have a data annotations validator. And if we use the app like this, it will, it will use the old validations, which will be still, available in .NET 10 as a fallback. And in this case, if I then look at the app and try to submit my my form, I only get a validation error on this field. And the reason for that is that in my model, I have some validation attributes on this property, but the rest are nested properties, which as we said in the beginning, is the limitation of the old system.component model, data annotations validator, which was used in the original Blazor validation implementation. But if we switch to the new validation implementation, which is as was done in manual APIs, is done just by adding this add validation call during your application startup, and then restart the app, we'll see all the new validations taking place. Just give me a second.
Sending good vibes your way for the live demo.
Sure. I couldn't help myself in doing this little trick with adding one line of code to get all the new features. Okay.
Do the magic.
Yes. Maybe in the meantime, I will walk you through the demo because I want to show some features in it. So it's we have a forum which has some model order here, and then there is like top level property, and then there are like nested properties. We have some customer details. We try to collect email and phone number and so on, and some addresses, and then there's a collection of order items, and all of this we want to validate, and we are still building. Oh my gosh. Okay. And
we need to get you a better machine.
Yeah.
Sure. Let's look at the models then, because this will be more important for the new features. The one thing to notice here is that now I have validatable type attribute on my order model. This is another difference, or this is a difference from the minimal API case, because as Safia said, in the case of minimal APIs, we are able to inspect all of the endpoints as you define them in your app, and discover the types to validate automatically. But in Blazor, the types that you want to validate are these form models, and unfortunately, because these are contained in Razor files, and Razor compiler, the thing that is responsible for compiling Razor files into actual C# code, is itself a source generator. That means that, and there is the fundamental limitation of source generators as of now, that you cannot pipeline output of one source generator into another. That means that we cannot inspect your models that you use in Razor files automatically. So that means that you need to opt in into validations of models explicitly, or to be more precise, you have to opt in by annotating the root type with this attribute. If you do that, the rest is discovered automatically. So for example, I have the order model is the root, and I have a customer model. If I inspect that, then this model doesn't use the attribute, or my order item models don't need it. So is it still building? Okay. Oh, no. Okay. Now we should be in our updated app.
Exciting.
Nice. And now if I submit my order, then I get a bunch of errors. So even nested errors. And let's go through the individual fields, because all of them are there for a reason. So this is the first one, is like very simple, property. This would be validated previously, so that's fine. Then we have the nested model here, which is if I have a customer model, and there I have some address models. The payment address is the first, so there are multiple levels of nesting, and I have my validations here as well, and those are validated. Now, you might be wondering why I have errors only here and not here, and that's because my shipping address is annotated with skip validation attribute, which is a new attribute that we are also adding, and because we wanted to give you an option to opt out of validation of certain properties. Because previously this wasn't an issue in the old validation implementation, because there was no nesting or no nested validations, but now there are, and you might you might want to not validate something. So this is the attribute to use. you can also annotate, use this attribute on types and on parameters in endpoints, for example, in minimal APIs. And it would work as you would expect. If you annotate a type, then all of the properties of that type are skipped. Okay, then if we add some values here, we can see that, if we do this and submit now, the form, okay, there is another error which we didn't see before, which is that we require at least one of these, and this is used to showcase that you can have custom validation attributes. We support those as well as as before. So you can do some like more complex validations, which, for example, inspect multiple properties of the type. And we also support the iValidatable object interface, which is shown here. We use it here in the demo to, like, if you don't have any, sorry. Oh, sorry. Okay, this wasn't expected, but this is actually, a good thing to show, because I was expecting that there would be an error about my missing, order items, but I still have this error here, which is, for another property, and this is used to showcase an issue that we were, just polishing up recently, and that is that the old validation implementation, which is, has been used in, in .NET for multiple years, has an order of validations, which short circuits if some previous validations fails. More precisely, if you first validate properties, and if you have some errors in the properties, then you don't validate type level validations, which means for the order is you validate properties. If those succeed, you validate attributes on the type itself, and if those succeed, then you validate the iValidatable object implementation, if there is any. So now what I need to do is provide some phone number here, and then I will get my error that I'm missing order items, which I can, I don't know, do something, get something here, and now I have my form fully validated. Okay, so to reiterate with what's new in Blazor, that you still use the old data annotations validator. You don't have to change anything in your Razor components and in your models, but you just add this line. And there is the edit requirement that if you want to use the nested validations, then you have to declare your models with at least the root model with this attribute, so it can be discovered by the source generator. And the additional, there is an additional limitation that the models have to be declared in C# files and not Razor files themselves, for this very same reason, because Razor files cannot be processed by the validation source generator. So that's the new implementation from the point of view of the user. But I thought that it might be interesting to see a little bit about how it is in these new validation infrastructure is integrated into Blazor, because it can be also like illustrative for the way you can use the new API to implement your own validation components. Because this is not the, if you have more specific needs than that are covered by our component, you can use the new APIs as well. So it's actually quite simple. The old data annotations validator, the thing that it did, if you look at the actual implementation, is that it used the edit context class, which is a thing that ties all of the Blazor implementation together. That's where we gather the validation state and the errors and so on. And it basically registered some event handlers on it, which were called when the framework required, or the framework noticed that you changed some field or that you submitted a form, and then perform the validations. And the validations previously were done, using the good old system.component model data annotations validator, which is the reason why the behavior was limited as it was. And we still have it as a fallback if you don't set up the new validations. But if you do, then we hook into the new implementation, which is done by getting validation options in the instance. But this is basically, and Safia, you can correct me if I'm wrong. This is basically the entry point for if you use the new validations as a user. This is the entry point, how you get your resolvers, and then how you get how you can execute the validations itself, right?
Yep.
Yeah.
And I think what's cool is if you look at the implementation for minimal APIs, which is done via an endpoint filter, it looks very similar. You get validation options, and then you get the validatable type info from the resolvers, and you query the validate. So it's kind of cool that the actual usage case for Blazor and minimal is like super small, and most of the heavy lifting's in the abstraction.
It's basically two or three methods. We
Yeah.
retrieve the validator, type info, and then we call validate async on it, and then we do a little bit of mapping because in order to display the the error messages and so on, and do the like highlighting green and red boxes and so on, we have to translate basically the validation results into our into the Blazor specific representation. But that's basically it. And so if you have more specific needs, you want to customize the behavior, for example, how the errors are displayed, you can implement components such as the data annotations validator and use the new APIs in a very similar way. And it has to be said that you can retrieve all the types that you need, the validation options. Sorry, I'm scrolling randomly. The validation options from the dependency injection, because that gets registered when you call the add validations during startup, and so you have everything you need.
And I think one interesting thing to call out is that there was an on error event that we added to the core validation APIs as a result of the Blazor requirement to need to be able to display errors in the form kind of dynamically. I don't know if we can find on validation error. Yeah.
That's because we don't hold like a string reference. We hold the instance to the object, so we need to map the instance to the error message essentially.
Yep. And this is the key that gets used in the error message and the instance on the form. Am I understanding that correctly?
Yes.
Yes. Yeah, and this is interesting from like design point of view, because Safia first designed the entire infrastructure, but she tried to, or you tried to implement it, or I guess as general as possible, but you had minimal APIs in mind, right? So when we started working with your implementation, because UI framework has a bit different needs than API framework.
Right.
These,
I mean, it's a Blazor specific thing. Like MVC would have worked fine.
Yeah. Well, I also like that we didn't, like, it wasn't a huge change to add. Like, we basically added one new property to the validate context, which to me was like, okay, this is a good test that this abstraction actually works, because we didn't have to like do crazy gymnastics or anything to modify the type surface that was exposed by the API to get it working. So that's pretty neat. And I think that was one of that was one of the conversations we were having while we were building this. It's like, okay, let's see if minimal API can use it, and then Blazor, and then we had kind of a litmus test of like, okay, can we kind of write a totally independent validation library on top of this as a way to validate the abstraction? So it was kind of cool to be able to use it for Blazor specifically and kind of see it work out.
Yeah,
Okay.
I think the main difference between the two was that like in the minimal API case you get all the errors and then you process them, and in Blazor you just process them as you get them. So I think it's like in both cases it's useful independent of the framework.
You may have shown this. I was multitasking a bit because of the release, so that's my excuse. But is there a way, are we able to integrate the validation requirements from the Open API on the minimal API backend with the front end?
Oh, that's an interesting question. So it works the other way around, actually, because right now we emit OpenAPI documents from your minimal API implementation. And so the built-in OpenAPI implementation will examine certain validation attributes that can be represented in OpenAPI, like min length and max length and string length and regular expression. And those will be included in your OpenAPI document. We don't really have like a spec first model in ASP.NET Core, so there's not really a story for like taking an OpenAPI document with existing validations and implementing those. But someone very enterprising could theoretically build something on top of the validatable type info
Okay.
resolver to like take an OpenAPI document and
But if I
apply
had if I had a project with a shared models class that both the API and the Blazor project use, then those would both point at that same validation requirements,
Yep.
right?
Correct.
So, which
Yes.
is the standard case there.
Correct.
Awesome.
Yes.
We had a few questions. Just so one is, and kind of opening it up here. Does this have any implications with Blazor Fluent UI? And then just kind of opening it up as far as, does it have implications with other UI, issues or whatever, UI libraries, components? Meaning,
So
I guess
principle
it
now,
just the validation just bubbles up, and from the point of view of a
Yeah.
control, it's just a validation.
yeah, it's just like you're getting extra messages, and yeah, the only thing that I can think of is if you wanted to implement like a custom validator message or something like that that showed messages in some special way, but I don't think anybody does that.
Okay.
Yeah, it has to be said that for Blazor, the change is only in the source of the validation errors and the messages, but the whole like presentation layer is the same as before.
Okay. There's a question here, and just again opening it up, the same validation mechanism as old ASP.NET MVC. Just generally, like, how would you compare this to like ASP.NET MVC or other ASP.NET things?
I think it's similar in that it's data annotations based by default. So we like respect things like the iValidatable object interface and attributes that implement validation attribute. But a lot of the infrastructure that you saw for the resolvers, the source generators, being able to customize resolvers is like completely unique to this new model. Validation in MVC is also a little bit different because it's like, well, deeply connected with like model state and the way binding errors are surfaced. This one I think is a lot more like extensible. Like there's the core validation stuff, and then there's like the Blazor data annotations validator component on edit form and the minimal API validation filter that talk to it. So I think the similarities pretty much end at the fact that you can use data annotations with it, which by the way, I know some people have varying opinions about data annotations. You can actually use the custom resolvers to implement your own validation logic that's not based on data annotations. So um, everyone is happy if they, depending on how much code they want to write.
Yeah, they can write their own source generator for all we care and like plug
Yeah.
it in.
Yeah.
But I mean, this was the reason for the like creating the new implementation, because hopefully it can be used across across frameworks. Previously, all of the frameworks like MVC and Razor Pages and Blazor and implemented their own validation based on the old public API. which is obviously wasteful. And at the same time, like this is like decoupling the source of the validation information from how the individual frameworks present the result, which is very cool, I would say. But at the same time, the old data annotations are so prevalent in .NET that we couldn't like just throw them out. So hence they are supported fully.
Okay. Let me see. That's basically all the questions related directly to that. But there were two people asking just generally about improvements to hot reload, and I wanted to ask too, like in terms of the validation stuff you showed, how any of that works with hot reload.
Ooh.
So that's an interesting question. I think the edits are probably supported. I don't know, Safia will know if we've done anything to support hot reload on the validator, on the add validation API.
No, I know there's sometimes custom attributes or like metadata update things that you have to annotate. I don't think
Yeah.
we've done anything in that regard, but the default behavior of like watch or hot reload might be sufficient. That's a good one though.
So
I mean,
yeah, I
notations
think
would be the same, right?
it's definitely a good one. Yes, but the code generated will not be the same, and we will need to like update the descriptors probably. That would be the thing. Yeah, we did a pass, for example, in ASP.NET recently in Blazor to just go through all the places where we have caches and things like that that need to be updated every time that you, or clear every time that you do a hot reload gesture, to just go and wipe it out. I am planning to write some instructions for our silicon-based friend Copilot, so that in the future we don't have to be doing this. We don't have to do what Safia just did. Like that was like, I remember there was this thing called metadata update or
Yeah.
something that like I had to do. We have a prompt, we have it on the repo, we do / do the hot reload thing and like get
I
it
like that
sorted
idea.
out.
So I don't have to remember what that API name is.
Yeah.
Yes.
Awesome.
Yeah. So yeah, I think that was a good one.
Cool. Okay. Well, that was basically all the questions we had.
Okay, I think I have one thing that I forgot to say, which I think I should, is that all of this for Blazor is coming as a part of the ASP.NET framework itself in .NET 10. You don't have to add any packages. This is relevant because previously we had attempt at like providing nested validations for Blazor with a special component, which had lovely name, object graph data annotations validator, and this type was released in a package that has 5 million downloads as of now on NuGet, but even though it has been deprecated for years now. So this is our attempt to do the things properly and in a way that users can now depend on, and we will support it for forever and ever as we do. And so that's that should make the people that are still missing this whole package happy, because I know there are some.
I guess one other thing to add, because you mentioned you don't need another package for this, is some of these new APIs are experimental. So the APIs that I showed around iValidatable info resolvers, the validatable info abstract type, all of the kind of nuts and bolts that make it up, they are marked as experimental. So you will observe that as you create custom implementations, you'll get like the experimental attribute warnings. That is in place because, as we mentioned, we see this being like a generic validations framework that other frameworks can build on top of. And we wanted a little bit more bake time on the API before we like committed to it. So please use it to extend stuff. Know that it's experimental and it might change, but that also means that because it's experimental, if you see something that needs to be improved or have ideas for changing the core logic, you can offer those ideas up, and we can actually, make breaking changes and stuff like that in a way that we don't typically have the chance to. I guess another interesting thing is like, um, Javier was working on something recently because that validatable type attribute that Ondrej was showing is actually one of the types that's marked as experimental. But for
Mm.
Blazor, we wanted to provide an option that didn't kind of dirty users' code with experimental attribute warnings for something that, for all intents and purposes, was kind of like an implementation detail for Blazor. So, Javier, do you want to share how we resolved that? Because I think that was kind of an interesting approach to take with it.
Yeah, so we essentially do something that like other source generators do and the framework does in many places, which is we are generating a compiler attribute that we put into your assembly into like a very well namespace. We are adding a global using by default, so that is already there for you to use. And it has the same name as validatable type attribute. So you can use that, but it's not part of the framework. It's just part of your app. And then when we mark the other attribute as non-experimental, we will remove this, and we will have some analyzer or something like that, or a code fix that just has the using. And with that, we kind of we are able to give you the experience that we want right now, without having to deal with the experimental warnings and all that stuff, and then have an easy path to upgrade.
Yeah. And this specifically is for Blazor, because for minimal APIs, the idea is that you don't need to use the attributes at all because we'll just discover them automatically. So you might see, I think it's in like the Razor SDK or something where we turn on
Yeah.
this behavior. Yeah. So
Yeah, I only turn it on when you have .razor files in your project, and you have to do you have an MS-build flag if you, for some reason, don't have any Razor file in your like Razor app.
So yeah, trying to balance like usability versus this is experimental and we want to like evolve it, and kind of give ourselves a get out of jail free card in case we decide to change things in the future.
Okay, there's an interesting question that just came in. So this is there's an annoying behavior where Blazor text input starts with a value null, but if a user touches it, it becomes an empty string, which triggers min-max length validation if you can't submit.
Yeah, so that is the browser doing that. The browser is the one setting it to null. Yeah, it's the browser. So the only thing that you could potentially do is have the property be a full property, or have the value be have the value that you bind to be a property, and then just check for empty and just set it to null, essentially, if that's what you want.
Yeah. And if you are really bothered, you can implement your own range or string length attribute, because we support custom attributes, which I know is not ideal, but there's always a way to.
Yeah.
Never mind. I wrote the feature, and I don't remember that I wrote the feature. There is bind get set that you can use for these cases where you get to manipulate the value before you set it.
Oh,
okay. So there are multiple ways.
Huh.
Yes, bind get set is the good one. I just forgot about the feature.
That's how you know you ship a lot of good features. You can't even keep track of all of them.
All right. Well, we're just about at time. And anything else to show or talk about in closing?
I think I saw a question pop up about documentation for this. We're working on rolling out official docs ahead of like .NET 10 RC1 for some of this stuff. The repo that I linked to has some in-depth docs that cover kind of the behavior, and you can kind of use it to look at the implementation code. But yeah, docs for .NET 10 RC1, hopefully. Yeah, there's a sample app.
Oops. Yeah. Okay. Bringing it back up. Yep.
Super fun. Yep.
Very cool.
Yeah, I highly recommend looking at the repo, because it contains a great explainer of all the concepts that Safia talked before in more briefly. Yeah, and I also want to say that we were building up the Blazor support in past previous preview releases, and some of this is coming up only in RC1 because we're doing some last minute polishing, which is also the reason why I was building up the demo locally, and it took some time. So I apologize for that, but we are really committed to get it in .NET 10 in production ready.
Awesome. Okay, well, I'm getting people to ping me about the preview release, which is very exciting. So that's out. And then we have an unboxing video scheduled for this afternoon. And I think, Ondrej, you're doing a demo on that. Is that right?
Oh, am I? Okay.
I don't know.
I will make sure. I will make sure that I will have it built before the demo then.
Or not. Maybe we'll see. Okay. Cool. All right. Okay. Thanks everyone for watching.
Thank you.
Bye.
Bye-bye.